This black powder holds huge potential. It's neodymium, a raw material that belongs to the rare earth elements, and it's found, for example, in these so-called permanent magnets, which are in high demand in the automotive industry. They are built into every electric car motor, as you can see at this factory of a major German car maker. They make electric motors compact, powerful, and efficient. But it's becoming more and more difficult for companies to get products made with rare earth elements.
Rare earth resources are not distributed evenly across the globe. There are mining areas with very high concentrations that are easy to extract. These are mainly in Asia, specifically in China. Over the years, this has led to the development of a monopoly with 98% of magnet production, as well as the separation and metallization of mined ore.
One startup is aiming to break this monopoly. The system makes it possible to recycle permanent magnets. It's brand new technology. The rare earth elements are separated from the magnets through a complex process. It's considered environmentally friendly because it runs on hydrogen. For the startup's employees, the first order of business is to learn. That's because expertise in magnetic technology has all but disappeared in Germany over the past 40 years. Now it's time for a fresh start.
In recent years, magnets weren't taught, not in chemistry, not in physics, not in material science, because it was a technology from which we had essentially moved on. Magnets had been a cheap commodity that we bought from China, but awareness that they are a key material has been growing again in recent years.
The biggest challenge for recycling is simply finding used magnets on the market. There are very few suppliers. At the moment, the recycling process is focused on old hard drives. These come from data centers or banks that are upgrading their hardware. They are inexpensive and easy to transport. First, the hard drives must be broken down. Otherwise, the machine cannot extract the rare earth elements. The magnet is installed in this corner. Permanent magnets are also used in wind turbines and electric cars. But many of these products are not yet being recycled because they are still in use. The market situation is unclear.
That is indeed a challenge right now, partly because there are apparently players in the market who are buying this scrap metal at very high prices, prices that make recycling completely uncompetitive. And we suspect that some of it is being shipped abroad and ultimately ends up back in China. But at the moment, that's just a guess.
Despite all the obstacles, full-scale production is expected to be up and running as early as next year. Funding has been secured by partner companies from Canada and the UK. This machine here comes from China and is actually supposed to press new magnets from recycled material, but it's still sitting idle. That's because Chinese experts are needed to get it up and running, but they haven't been allowed to leave the country yet. China is trying to prevent the knowledge of magnet production from reaching Germany and Europe, and it's imposing extensive export controls.
The export regulations are open to interpretation. In some Chinese regions, there are no issues at all. In others, there are restrictions regarding who the customers are and what the products are intended for.
Chinese export controls are making it harder to do business. German manufacturers like MUT in Jena are benefiting from this. More and more Western countries are turning to a circular economy to reduce their dependence on China. The specialty firm's order books are full, and it is looking to hire new employees. The company acquired its expertise in recycling plants from the University of Birmingham. Nevertheless, it is unable to completely shake off its dependence on China.
Europe is pursuing a strategy to bring more facilities of this kind online, but this is still insufficient to meet global demand, at least not yet. Right now, because of the shift to electrification across all sectors, the overall demand for magnets is simply much greater than what is being returned to the market from end-of-life applications.
Automotive supplier ZF labels the magnets it installs so that the rare earth elements they contain can be easily identified. This is intended to make recycling easier and thus make the circular economy more efficient.